All right, number 20. We've got three charges on the y-axis. One is at the positive 6 mark, one is down at the negative 4 mark, and this other one is somewhere in between. And what we need to do is find our equilibrium. So we're going to solve it just like we learned with all of our 5 steps. Set the force between 1 and 2 equal to the force between 2 and 3. And you're going to say, well, this is a grand total of 10 meters, so you're going to say distance 1 and 10 minus distance 1 over here. And you'll go through and algebraically solve it. You'll cross multiply, you'll square root, and you'll solve for the location of the middle charge. Remember, those are all microcoulombs, but luckily you can cross those out. You can get rid of the micros. And then 21, very similar. We have a positive charge, and this negative charge is somewhere in between. So you'll set the forces equal, and you'll say distance 1 and 40 centimeters minus distance 1 over here. And again, you'll go through your steps and solve it. 29. When defining an electric field, why must the test charge be very small? The test charge needs to be very, very small, almost considered to be nothing, so that it doesn't contribute to the electric field that you're measuring. Number 32. Find the electric field at a point midway between two charges. So maybe we're looking at this situation. You have two charges and we're finding the electric field at a point midway between them. So you're going to find E over here for that charge, and then you're going to find E over here for that charge. And that's it. Use half of the distance here because it's finding it at the point midway between them. And then you have number 34. Calculate the net charge on a substance that contains 7 times 10 to the 13 protons. So you're going to multiply by that, and that gives you charge. And then you have a substance that has 4 times 10 to the 13th electrons. I might have read that backwards, but no, that's right. So you multiply by there to get the number that you have, and you get your charges, and you're going to add and subtract to find net charge. And 34. I did 34. I'm sorry. 37. Consider the three charges arranged as shown below. What is the electric field strength at a point 1 centimeter to the left of the middle charge? So let me assemble a little drawing here. We've got a gap, and then you got this here. So we're looking at these four here. And they're saying a 1 centimeter, and I believe that 1 centimeter puts you 1 centimeter from the left charge, so about there. So you're going to find E for this one, E for that one, and then E for that one. Then part B was the magnitude of a force on another negative charge that is inserted at that point right there. And so you'll put that charge in it, and you'll find force 1, 4, 2, 4, and 3, 4. And then you have to do addition and subtraction to be able to do that problem. And lastly, number 40. The moon gives you the mass, is bound to the earth, gives you the mass by gravity. If instead the force of attraction was a result of each having a charge of the same magnitude but opposite sign, what quantity of charge would have to be placed on each to produce the required force? So, use the mass of Earth and mass of the moon, find the force of gravity between the Earth and the moon. Then, solve that problem. Once you have that force, take that force and set it equal to this force. So, force of gravity between Earth and moon here, Coulomb's constant, and the distance is given, in the book somewhere. You can find that back in chapter, what chapter was that? Chapter 7. You can find the radius there, and you'll need it actually to find the force of gravity. Then you'll multiply that in there, you put your radius in here, Coulomb's constant, and you'll solve, since they're saying these two charges are going to be equal to each other, and figure out how big these charges had to be, and they're probably very, very big charges. Okay? Good luck with that.